Next couple of video clips will cover the rest of Chapter 4. We'll be tested on sections 4.2 to 4.4. And by the way, you'll be able to tell what you're being tested on when you look at the top of your assignment. So let's open up, for example, the week 3 homework. I'm going to preview it here. And when you look up at the top, this question says, question 1, 4.1.1. And that's the test number from the test bank that this is coming from. And if it begins with 4.1, that means that this question relates to section 4.1 in the book. Okay, so this would mean like section 4.1, question 1. It might be kind of valuable for you to keep your eye on that so you know exactly what material each question pertains to. There are a few exceptions. I've seen some that are numbered funny. They begin with like CQR or a few letters like that, but otherwise, almost all of them are numbered like this, that they have the section number first. So keep your eye on that. All right, let's go back to my lecture outline. I felt that sections 4.2 to 4.4 kind of are all part of a continuous lesson, which we could call compound probabilities. Some of the key words that we're going to study here are and, or, not, and given. By the way, I think I might preface this up front with a little bit of a disclaimer. There's a lot of overlap between math and language in this class. And students love to complain about what they call word problems. I guess I can kind of understand that because it's really not the math that makes things complicated. It usually tends to be the language. The rules of mathematics are very clear cut. The rules of language are really sloppy. So that's when math tends to get difficult, is when language is not helping us out. So these are some key words. We're going to be studying things like the probability that one thing happens and another happens, or given that you choose one of these, what's the probability of that? So these are some key words that we can keep our eye out for. But because language is sloppy, they won't always, the questions will not always literally be worded with a key word in them. Okay, so these are not always going to be flashing red beacons, say, hey, do this. Sometimes they are. But for example, some questions will be worded like, what's the probability that I will eat spaghetti for dinner tonight and it will rain in Barcelona? Okay, well, there's the key word and we're going to learn that, oh, that's easy. When you hear and, you think multiply. But consider this question. What is the probability that I will eat spaghetti tonight while it rains in Barcelona? Okay, so in that wording, I didn't use the word and. So we have to kind of think through to the spirit of the question. If you could reword that question using one of these words, you would have to use the word and. So that's what you kind of keep your eye out for. Or some questions will be very clear-cut using the word given, like if you choose a student at random, what is the probability that she got a B in this class, given that she was a female? Okay, well, there the word given is just handed to us on a silver platter. But consider the following wording. If we choose a female student from this university, what is the probability that she got a B? Uh-oh, they didn't use the word given that time, right? They just kind of like incorporated the given part into the question. So again, we're going to learn these keywords when they're handed to us on a silver platter, but I just want you to caution you that sometimes they're not. And therefore, a very important part of being a good probability student is being able to take what I call sloppy English and be able to translate it using the words and, or, not, or given. All right, that being said, let's take a look at today's menu. The three main topics in this lecture are, we're going to start out with some basic starting rules. We will talk about issues of dependence and conditional probability, which, by the way, are related to the word given. And then we're going to demonstrate some examples using a contingency table format. Starting rules are correspondences between these key probability words and the operations of arithmetic. So essentially, there are always caveats, exceptions, and special cases, etc. But remember, I'm not going to delve too deeply into those in this class. I don't think we need to. So I'm going to pretty much stick to the basics. And the basics are the following. The probability of not getting some certain event is generally related to subtraction. So when we see not, we think minus. And I realize now that I covered this topic in the section 4.1 lecture, although it actually appears in section 4.2. So that one was, I gave that to you a little bit out of place. But by the time I realized that my videos were all done, and I wasn't going to go back and redo the whole video for that. The word or is associated with adding. Or means plus. And the word and is related to multiplication. And means times. And that meaning of the word and, multiplication, works for both fractional probabilities as well as whole number sizes of sets. It applies to sets whether you're choosing from different sets or from one common set with what's called repetition allowed. And we're going to do an example of that in a moment. By the way, we're going to see in a different context, that the word and is also associated with overlap when we work on one of these contingency tables. So that word and is a little bit on the complicated side. Done our examples using the word not. So let's do some using the words and or. So here are 3 examples that I came up with that illustrate the usage of the word and its connection to multiplication. Question number 1. The probability of flipping heads in a coin is 1/2. The probability of rolling a 3 on a die is 1 out of 6. What is the probability of flipping heads and rolling a 3? Well, the word and is associated with multiplying, so essentially we're just going to multiply these 2 probabilities together. That's 1/2 times 1/6, which is 1/12. By the way, I'm afraid I do not have the time to review fraction arithmetic. So if you're a little bit rusty on that, you'll have to do a little bit of outside studying to review the mechanics of adding, subtracting, multiplying, or dividing fractions together. But there's this wonderful resource out there. It's called the World Wide Web. And believe me, you'll be able to find hundreds and millions of videos that teach you the basics of arithmetic if you need to brush up on them. So because fractions are probabilities, we will need to be pretty competent with fractions, decimals, and percents in order to get through a probability class. But basically, when you multiply fractions together, remember you just multiply straight across the top. 1 times 1 is 1, and straight across the bottom, 2 times 6 is 12. That's basically enough for that. Okay, the concept here is that and means times. Question number 2. Now, number 1 involved fractional probabilities. Number 2 is going to involve whole number sizes of sets. And this is one of those examples where we're choosing from multiple sets, different sets, like the note said here. So when you go to the ice cream shop, you can create a sundae by choosing your flavor of ice cream, a wet topping, and a dry topping. Interesting. And. Oh, okay. And means times. There are 20 flavors of ice cream to choose from, 10 wet toppings, and 5 dry toppings. So how many different sundaes could you create? You want to take a wild guess? You'll probably get it right. Yes, that's right. The key word and suggests multiplying. So since we're grabbing items out of 3 sets, ice creams, wet toppings, and dry toppings, we're pulling together one of each to make a sundae. So the answer here would just be 20 times 10 times 5. So believe it or not, we could create 1,000 different sundaes in this shop. 1,000 sundaes. That would be a good name for an ice cream shop, I think. All right, in number 3, we're going to be illustrating this final principle for multiplying. We're going to be drawing items from just one set, one common set, when we're allowed to repeat them. Repetition allowed. In the Martian culture, names are chosen by combining letters at random. So the Martians don't care about vowels or consonants or phonetics. You could have a name like BQAPRZD. Okay. How many different 4-letter names could be created, assuming that letters can be repeated? Okay, so in this problem, we're going to be choosing letters from only one common set, the alphabet. Interestingly enough, Martians used the Roman alphabet with 26 letters. It's a quirk of history. So each time we choose a letter, we have 26 possibilities, and we're going to choose 4 of them. We can write out the number of possibilities this way. There are 26 letters to choose from for the first letter in the name, and 26 for the second letter, and 26 for the third, and 26 for the fourth letter. So all of those ands become multiplication signs. So we're really multiplying 26 times itself 4 times, aka 26 to the 4th power, which happens to be this particular number. Key here is that we are allowed to repeat these letters. So that's a phrase that'll come up in your homework sometimes. It'll say something like, if repetition is allowed, or if items are replaced in the set before you choose from the set again. There's a whole other system of counting principles involving selection without repetition allowed. And that topic is way more trouble than it's worth. It's the bane of students everywhere, and it really doesn't enlighten us or prepare us for the rest of the statistics class. So I am deliberately staying out of that topic altogether. If you've heard horror stories about factorials and permutations and combinations, you're in luck, because we're not going to cover those. All right, let's do a couple of examples of OR and how it's represented by addition. When rolling a regular 6-sided die, what is the probability of rolling a 2 or a 6? Okay, so when we see the keyword OR here, we think about adding. So we've got to think about the probability of rolling a 2 as well as the probability of rolling a 6, and we're going to add them together. And we've seen this problem before, in one at a time. Excuse me. Each one of these numbers represents only one side of the die. The probability of choosing each one is 1 out of 6. The word OR indicates that we're adding them to each other, resulting in 2 out of 6, which we could reduce to 1/3. And then finally, what is the probability of rolling 4 or more? So in this case, we kind of have to enumerate which numbers on a die are 4 or more. Let's see, that would be 4, 5, 6. Aha. So this problem really comes down to what is the probability of rolling a 4 or 5 or 6, right? So often, again, we have to do a little bit of translating. The rules of numbers are very cut and dry. The rules of English are very sloppy and ridiculous. They add up to 3 out of 6, which you could reduce to a half. Maybe it's a little bit easier to follow when I separate the steps vertically.